our problem is a 100-gram block attached to a spring with spring constant 2.5 Newton per meter oscillates horizontally on a frictionless table. Its velocity is 20 centimeters per second when x is negative 5 centimeters, measured from the equilibrium point. First, we'll solve what is the amplitude of the oscillation. Well, the law of energy conservation states that the total energy of the system remains the same. No energy gets destroyed, but it's just converted, transformed, or transferred from one form to another. The equation for the kinetic energy is kinetic energy is equal to half mv squared. The equation for angular frequency of the object when it's in simple harmonic motion is angular frequency is equal to under root of k by m, where k is spring constant and m is the mass. So we just plug in the numbers, right, to find the angular frequency, and we get 5 rad per second. Nice. So we got this, but amplitude can also be restated as we have done in equation 1. What it is basically that we took the law of conservation of energy, which is kinetic energy of spring plus initial kinetic energy is equal to kinetic energy of final, and we plugged in this thing in there, and we just rephrased it to give us equation number 1. Cool. We plug in the numbers and we get the amplitude is equal to 6.4 centimeter, which is the amplitude of the oscillation. Now, part B asks us, what is the block's maximum acceleration? That's relatively easy. So acceleration is the amplitude multiplied with the angular frequency, which is 5 into 0.064. We get 160 centimeter square, centimeter per second square. The third part is, what is the speed of the block when x is 3 centimeter? Well, we used the equation to find this, right? So we can reuse this equation to find v, but the thing to note is over here our amplitude is x, so we just put that in right there. It makes it easier to understand. Put in the numbers and we get velocity is equal to 28.3 centimeters per second when x is equal to 3. That's pretty much it.